So now we will discuss pure resistance, inductance, and capacitance, and it is connected to an AC supply. So first, we will discuss the pure R. Resistance denoted by R, inductance by L, and capacitance by C. So this is the circuit diagram of a pure resistance connected to an AC supply. So our AC supply has an equation: instantaneous voltage is equal to maximum voltage sine omega t. The inductance also has a voltage source equation, Vm sine omega t, and also in capacitance. So there is a current flowing in each circuit. Purely resistive. So the behavior of a pure resistor in an AC circuit is exactly similar to that in DC circuit. The laws governing resistors in a DC system may therefore be applied to AC circuits, assuming that the RMS values of voltage and current are used. Also, current and voltage are always in phase in resistor circuits. So the main idea here is that in a pure resistance, so ang approach natin dito is like in DC system. Okay? Given, we will use the RMS voltage and RMS currents, and also remember that the voltage is in phase with the current. We have an impedance here, so Z is for impedance. Our impedance in pure resistive is also equal to R. Z is equal to R. Computing the current flowing in this circuit is equal to voltage divided by R, Ohm's law. So this is the waveform of a pure resistive. So we have here the sinusoidal wave of a voltage, the blue one, and sinusoidal voltage of current. So as you can see, they are in phase with each other. The maximum voltage, the maximum current. So computing the power of pure resistive, it is equal to our general formula for power. It is applicable in all computations. That is equal to P is equal to EI cosine theta. So P is equal to EI cosine theta. Since our resistance, since it is a resistive, diba, our voltage and current are in phase. So there is no angle between the voltage and current. Cosine theta here will be 0. P is equal to EI cosine theta. What is the angle between V and I? So that is 0. So cosine 0 is 1. We will compute the power of a pure resistance. That will be equal to the power equal to voltage times the current. So if the voltage is in RMS and current is in RMS, so our power will be in RMS also. Okay? So multiplying this voltage and current, since this is in a positive V times positive I, that is positive P. Negative V multiplied by negative current is equal to positive power. So ganun lang. So in resistive, yun yung nagko-consume ng power, yung resistive loads nyo, yung ilaw, mga electric fan, ganun, mga resistive loads in your home. Sila yung may consume na power. Purely resistive, equation of instantaneous current is equal to Im sine omega t. Equation of instantaneous power, small p, is equal to Im 1 minus cosine 2 omega t over 2. So this PowerPoint. No, binase ko lang dun sa mga videos na pinost ko sa MVLE ninyo, yung pure R, pure L, and pure C. Equation of average power is equal to P average equal to EI over 2. So, E and I are in maximum, or P average, or the P power is equal to EI cosine theta. So, instantaneous power is what is consumed at the moment, and average power is the power taken on the entire cycle. So, next is the purely inductive. A pure inductor in an AC circuit takes a current that lags behind the impressed EMF or the voltage by exactly 90 electrical degrees, storing and releasing equal amounts of electromagnetic energy during successive quarter cycles. The average energy per cycle involved in such a circuit is 0. This means that the average power delivered to an inductor is 0. So this is the circuit diagram. We have an inductor here, L, and there is a current flowing at our source voltage is equal to EM sine omega t. So our XL, or the inductive reactance, okay, XL is equal to omega L, or our omega is 2 pi F multiplied by the inductance. So, XL is the inductive reactance, is equal to omega L equal to 2 pi FL. F is frequency, L is the inductance in henries. So, IT is equal to VT all over XL. Here we have R is equal to 0 kasi this is a pure inductive reactance. The Phasor diagram of an pure inductive reactance is the voltage here as the reference and current lags by exactly 90 degrees. Okay? If you rotate this phasor or vector, it will come up with this sinusoidal waves. So this is the voltage. It is from the reference, so kaya nag-start dito. Ito naman yung I, it started at a certain value here at maximum. Okay? So kaya nahuli siya ng angle theta. This is 90 degrees. The wave of a voltage, and the red one is the current. So, instantaneous voltage is equal to EM sine omega t is equal to L di over dt. L is the inductance of the coil in henries, and di over dt is the rate at which the current is charging. So, instantaneous current is equal to EM over omega L times sine omega t minus pi over 2. So, this is our equation for the current. I is equal to EM sine omega t minus pi over 2. So, this is t. This pi over 2 represents your 90 degrees. This is in radians, pi over 2. And since this is instantaneous current, we will divide your voltage into our omega L. So, omega L is our XL. Okay? So, I is equal to EM all over XL times sine omega t minus pi over 2. So, this negative pi over 2 represents our phi. Okay? The phase angle difference in our case number 2. So, our voltage naman is equal to EM sine omega t because it started at our reference. This one. So, the equation of this current is equal to I is equal to Im sine omega t minus pi over 2. Or, I is equal to Im sine omega t minus 90 degrees. Next, instantaneous voltage. So, Im is equal to Em over omega L. Inductive reactance is XL is equal to omega L equal to 2 pi FL in ohms. So, the unit for XL is in ohms. Inductive reactance. This implies that the voltage and current are out of phase by 90 electrical degrees. So, instantaneous power, P is equal to negative EI sine 2 omega t. Average power for an pure inductance is equal to 0. From our general formula a while ago, P is equal to EI cosine theta. This theta here is equal to 90 degrees. So, P is equal to EI cosine 90. So, cosine 90 is 0. Therefore, the power consumed in a purely inductive reactance is equal to 0 watts. Okay? Equal kasi yung value ng negative half cycle sa positive. So, magka-cancel yung negative, negative, and positive. So, you will end up 0 power. Next is the purely capacitive. A perfect capacitor in an AC circuit takes a current that leads the impressed EMF by 90 electrical degrees, storing and releasing equal amounts of electrostatic energy during successive quarter cycles. The average energy per cycle involved in such a circuit is 0. This means that the average power delivered to a capacitor is also 0. So this is the diagram of a pure capacitive connected to an AC source. So, a current flowing, we have the XC, which is the capacitive reactance. So, capacitive reactance. In pala kanina, in purely inductive, our impedance is equal to XL. Sa capacitive reactance naman, our impedance is equal to XC. Kasi walang resistive load. XC lang yung nasa circuit natin. The Phasor diagram of a purely capacitive reactance is the current leads the voltage by exactly 90 degrees. Kung kanina, nasa baba yung current by 90 degrees kasi inductive, ngayon naman nauna si current by 90 degrees with respect to our reference voltage. So, instantaneous current is equal to I is equal to Im sine omega t plus pi over 2. Plus naman means leading yung current. So, Im is equal to omega c Em. Im is equal to omega c Em. Capacitive reactance is equal to Xc is equal to 1 over Wc. So, from our Ohm's law kasi, di ba? V is equal to I Xc for pure capacitive, V is equal to I XL for pure inductive, V is equal to IR for pure resistive. So, our Xc is equal to 1 over omega c. If we try to compute this current, we will end up getting I is equal to V all over XC. So our I is equal to V all over, what is our XC? Sorry, this is C, not L. Omega 1 all over omega C. So therefore, our I will be equal to omega C multiplied by the voltage. I is equal to omega C EM. C is the capacitance in farad. The unit for capacitor is farad. Instantaneous power, P is equal to EM IM over 2 sine 2 omega T. So the average power naman in pure capacitive reactance is also equal to 0 kasi EI, P is equal to EI cosine theta. Again, our cosine theta is equal to 0 kasi this is 90 degrees. The voltage between E and I, the angle, not the voltage, the angle between voltage and I is 90 degrees. Yun yung power factor na cosine theta. So, cosine theta is 90. Cosine 90 is 0. Therefore, the P in a pure capacitive is equal also to 0. Okay? So, our power factor is the angle between the voltage and current. This is equal to PF equal to cosine theta. Okay, this theta or cosine of power factor is angle between voltage and current. Okay. Example number 1, a large room is illuminated by 20 150 watt and 30 100 watt lamps. If the circuit voltage is 116, calculate the total current. So number 1, we have 30 pieces of 150 watts. So that is 20 times 150 is equal to our P1. So P1 is equal to 3,000 watts. Then we have 30 times 100. So that is also 3,000 watts. The total power will be P1 plus P2. So that is 6,000 watts. And our voltage is 116 volts. Calculating the total current. So this is a resistive load kasi it is a lamp. That's why our power factor here is equal to 0. Or unity. Power factor is equal to 1 kasi cosine 0 is 1. So, from our formula, power is equal to current multiplied by the voltage. So, current will be 6,000 divided by 116 volts. That is 51.724 amperes. Next, number 2. Calculate the resistance of a load that takes 1,500 watts from a 220 volts. So, simply P is equal to IE. Calculate the resistance. We have another formula. P is equal to I squared E. I squared R. Sorry, this is I squared R. But the given is voltage. So, another formula is P is equal to E squared over R. Getting the value of R, we will have E squared all over P. So 220 squared divided by 1,500 watts. So the resistance will be 32.267 ohms. Next, number 3. How much power is represented by a circuit in which the voltage and current equations are E is equal to 150 sine 314t and I is equal to 42.5 sine 314t. We have an equation here where your instantaneous voltage has an equation of 150 sine of 314t and instantaneous current 42.5 sine of 314t. So as we can see here, the voltage and current has in the same phase or they are in phase kasi walang value yung phi and they have the same frequency. So the maximum voltage will be equal to 150 volts and maximum current is equal to 42.5 volts. But we are required, yes, how much power is represented by a circuit? So we will multiply to get the maximum power that is equal to EM IM. For the RMS naman, P RMS or simply P RMS or simply P, that is equal to E RMS multiplied by I RMS, or P is equal to E I. Basta walang subscript yung mga quantities natin, it is in terms of RMS. So if we get the maximum power, that will be equal to 150 times 42.5 equal to 6,375 watts. Also, if we will get the effective power or RMS power, so 150 all over square root of 2 times 42.5 divided by square root of 2. RMS power will be 3,187.5 watts. Okay. Number 4, a coil of wire having negligible resistance and an inductance of 0.248 Henry is connected to a 117 volts 50 Hz source. Calculate A, inductive reactance, B, the current, C, the maximum power delivered to the inductor, D, the average power, and write the equations for the instantaneous current and instantaneous power. So this is number 4. Our resistance is negligible and the value of our inductance is 0.248 henries. We have connected to 117 volts and 50 Hz frequency. This is our circuit. So this is the inductor and our instantaneous value or instantaneous equation of voltage here will be E is equal to EM sine omega t. Omega is 2 pi f, that is 2 pi times 50 is equal to 314.16. So the value now of our instantaneous voltage equation is 165.463. So 117 times the square root of 2 sine of 314.16 t. Letter A, XL, inductive reactance is equal to 2 pi FL. So that is 314.16 times 0.248. And you have 77.918 ohm, 912 ohms. The current V is equal to IXL. So I is equal to 117 divided by 77.912. That is 1.502 angle negative 90 degrees. So this angle here represents that the current lags the voltage by 90 degrees. So this is I, and this is your V. They are displaced by 90 degrees, kaya may angle negative 90 yung current. For the maximum power, it is the product of the voltage E and the I. So we have 117 multiplied by 1.502. Or you can use the E maximum divided by square root of 2 times I maximum divided by square root of 2. You will get 175.734 watts. For the P average is equal to EI cosine theta. So our theta here is 90 degrees. Cosine 90 is 0. So the P average of our circuit now will be 0 watts. For the instantaneous current equation, I is equal to 1.502. This is our IRMS multiplied by square root of 2 para maging I maximum. Sine of 314 t minus 90. So this 90 here represents the phase angle or the angle phi. That this current lags 90 degrees. Next example, a 45 microfarad capacitor is connected to a 118 volt 60 cycle source. Calculate A, the capacitive reactance, B, the current, C, the maximum power delivered to the capacitor, and D, the average power. Write the equations for the current and the power. So we have a circuit, capacitor connected to an AC load which has an equation of E is equal to EM sine omega t. So our omega is equal to 2 pi f, that is 2 pi times 60, that is 376.99. And then our maximum voltage is 118 times square root of 2, that is equal to 166.877. So our equation for our source voltage is E is equal to 166.877 sine 376.99 t. For the capacitive reactance, XC is equal to 1 over 2 pi FC. So 1 all over 376.99 times 45 micro. equal to 58.946 ohms. For our voltage or current, from our formula, Ohm's law, V is equal to I XC. Our R is 0. So, I is equal to 118 divided by 58.946 is equal to 2 angle 90, positive 90 for polar form. For the maximum power, PM is equal to EI, that is 118 times 2, equal to 236 watts. Average power is equal to EI cosine theta. Our theta is 90 degrees. Cosine 90 is 0. That's why we have 0 watts in P average. For the equation of the instantaneous current, I is equal to Im sine omega t plus 90, or Im sine omega t plus pi over 2. Our RMS current is 2 multiplied by square root of 2 para maging Im, that is 2.828 sine of 376.99 t plus 90 degrees, or pi over 2. For our instantaneous power, P is equal to EI sine 2 omega t. So 118 times 2 sine of 2 times 376.99 t. So our instantaneous power equation is 236 sine of 754 t.